Hello, we're going to get started going through the Chapter 4 review. Please fast forward to the problems that you don't know how to do. So the first problem is in vertex form. So we can either use our transformations. Looking at this one, it is going to the right 2 units. It's going up 6 units, and then the A is positive, so it's going to be going upwards. So that in itself can help us graph it. Again, we're going to the right 2. We're going up 6. We make that vertex, and then our A is positive, and so we make a parabola that is going upwards. And then from here, we're going to answer all the questions off of it. So the vertex would be the opposite of this number, so positive 2 and then positive 6. The axis of symmetry is the vertical line that splits it down the center of our parabola, so it's x equals, and then whatever the x value is of our vertex, so x equals 2. The max or minimum, so our vertex, notice this is the lowest point on our graph, so we're going to put that it is the minimum. The domain on a parabola, it doesn't matter whether it's pointing upwards or downwards, it's going to be all reals. And then the range is our y value, so we're going to be looking at this y value of 6. And notice at 6, the arrows are pointing upwards, so y is going to be greater than or equal to 6. Now this next one, number 2, if you freeze on the test with your transformations, you can use the graphing calculator. So you could type in your equation. Click graph. Notice we get this problem. Instead of guessing what this vertex is, I would go to second trace, and then it's the highest point on the graph, so maximum. And then it's going to say left bound, so we're going to arrow over until, notice our vertex is about right here, so we want to be somewhere on the left of it. Click enter, and then we go back up to our vertex. Now we want to be somewhere to the right of it, anywhere on the right side. Click enter twice. And then it says the maximum is -4, -3. And you can round on that. So our vertex, again, is -4, -3. Our axis of symmetry is going to be the x value, so x equals -4. Our vertex is our maximum value. It's the highest point on our graph. The domain is going to be all reals. In our range are possible y values. We're going to use that -3. Notice that the arrows go downwards on our graph, so it's going to be y is less than or equal to -3. Alrighty, for number 3 and 4, they just want the graphs. So one option that you have, you can just go and use your graphing calculator again. So we have -x² minus 2x plus 3. We're going to click graph. And we would just sketch that graph. If you do want it to be more accurate than just sketching that graph, to go to second graph, and then they're going to give you a t-chart of coordinates that fall on your graph. So you could graph those points and get that parabola. But all that I'm looking for just is a rough sketch. Kind of notice how it goes like this. And then we have our graph. Alrighty, for number 4, if you did not like using the graphing calculator, how you can do this one by hand, we can use x equals -b divided by 2a. So that's going to help us find that axis of symmetry. So this would be our a, our b, and our c. So we would do -4 divided by 2 times our a, which is 3. So +4 divided by 6 is 2/3. So then that's our x value. We still need our y value, so make our t-chart. We're going to plug in 2/3. So we're going to plug that into our equation. We can write negative 0.3 repeating, or we can just go to math, fraction, enter. It'll give us a decimal. So then that is going to be where our vertex is. So we're going over to 2/3 and then down to negative 1/3. So over to 2/3, again close to 1, and then down just a little bit to negative 1/3. So that is our point. And then from there, notice her A is positive, so our parabola is going to be going upwards. If you want to make it more accurate, plug in another coordinate. So if I plug in 0 in for my x's now, I have 3 times 0 squared minus 4 times our 0 plus 1. And I end up with 1. So 0 and then 1 is a point. I reflect that over my axis of symmetry, and then I get my parabola. Now the next two problems want us to factor. For this one, the first one, we can do our grouping method. So take our A times our C. So 4 times 1, we get 4. So we need to see what multiplies to 4 but adds up to the middle term 4. So the combination is positive 2 and positive 2. If we multiply those, we get 4. If we add those, we get positive 4. So we're going to replace that with our middle term, plus 2c plus 2c plus 1. And then do our grouping. So the greatest common factor of the first two terms is 2c. What we have left over is 2c plus 1. The greatest common factor of the next two terms is just 1. And then we have 2c plus 1 left over. Notice what's in the parentheses are the same, so that's going to be one set of parentheses. And then what is on the outside is going to be the other set of parentheses. Now, another way that you could have done this problem, notice it's one of our special cases, so that the first term and the last term are perfect squares. So anytime that you notice the first term and the last term are perfect squares, then you're going to take the square root of the first term, that's your first terms, square root of the last term, so that's your last terms, and then the middle term is positive, so both signs are positive. That middle term was negative, both signs are going to be negative. That middle term is not there, and it's just minus 1, then that means you would have a plus 1 and then a negative 1. If that was then no middle term but plus 1, then you would have to have plus 1i and minus 1i. This next one, again, you can see it's a perfect square, so it's going to be one of our special cases. So square root of g squared is g. Square root of 49 is 7. The middle term is negative, so we just need one positive and one negative. That cancels out the middle term. And then if we take positive 7 times negative 7, we end up with negative 49. So we don't need the i's on this one. That would just be our final answer. The next two problems is saying, use the graphing calculator to solve each equation. Give each answer to at most 2 decimal places. Notice I put underneath that you could also, if you don't like the graphing calculator, use either the quadratic formula or factoring. So for this problem, let's use, for this first example, the graphing calculator, and then the next example we'll use the quadratic formula. So we go to our y equals, and we have 5x squared plus 9x plus 4. Make sure if the equation is not set equal to 0, we want to do that first off. Then we're going to graph this. The problem is asking for what are the solutions, so we want to know where it crosses the x-axis. So we might have to zoom in a little bit on this one. Okay, you can barely see, but it's going to cross at 2 places because it does go underneath that x-axis. So we should have 2 solutions for this one. So we're going to go to second, trace. We're going to go down to 0. And then it says left bound. So we're going to notice we want to find the solution on the left, so we're going to go to the left side of it, click enter, and then we're going to go underneath that solution. Click enter, enter, and we get x equals -1 for one of our answers. Okay, and then we need to do this again, second trace. We're going to go to 0 again, click enter. But now we want to find the right side, the solution. So we're going to go underneath, click enter, go above, click enter, enter, so it knows we want to find that right solution. And it's negative 0.8. And so then that would be our answer. Now again, if you don't like the quadratic formula, you're not forced to use that quadratic formula, or the graphing method, sorry. So another option that you have, you can use that quadratic formula. So we're going to label our A, our B, and our C. And then I'm going to write down our quadratic formula. So we have negative 2 plus or minus negative 2 squared minus 4 times our A times our C, all divided by our 2 times our A. And then from here we're going to simplify it down. So we have the two negatives would cancel out to be positive. Negative 2 times negative 2 is 4. And then we're going to multiply all these numbers together. So we have 4 times 3 times 7. We end up with 84. These two negatives are going to cancel out, so we're going to get a positive 84 divided by negative 6. So 2 plus or minus, we get 88 underneath there, divided by negative 6. From here, you can leave that as your final answer. Another option that you do have, you can write the square root of 88 as a decimal. And you get 9.38. So you can think of it like this, and then you could go ahead and simplify it further, that you could add to get the one answer, subtract to get the other answer. So if we take 2 plus 9.38, click enter, divide by negative 6, we get negative 1.896, so we'll just round to the hundredths place. And then if we subtract now, 2 minus 9.38 divided by our negative 6, we get 1.23. So again, I would either accept this as a final answer, or you can reduce it down to the decimals. Alrighty, for number 10, I crossed out number 9. If we go back to that, we did not do by completing the square, so you will not need to know how to do number 9. Number 10 is putting it in vertex form. So I'm going to write above what our vertex formula is. Okay, so for this problem, notice this is our A, our B, and our C. So our A in standard form and our A in vertex form are the exact same. So our A is going to be 4. Alrighty, from here, our H and our K is just going to be what our vertex is. So I would go ahead and graph this. Okay, we need to find that vertex. We're going to go to second trace, minimum. We want to go left bound, so to the left of that vertex, to the right side of that vertex, and we get negative 1 at negative 7. So since this is going to the left 1, we want to do the opposite, so we're going to add 1, which means it's going to the left 1, and then it's going down 7, so instead of a plus sign here, need to put a minus sign. So that's going to mean that it's going down 7. So then that would be my vertex form. If you did not like the graphing calculator, you're going to find the vertex like we did in problem number 4, using this equation x equals negative b divided by 2a. That will help us find the x value, and then once you solve for the x value, you'll plug it back into the equation to solve for your y value. Alrighty, for number 11 and 12, again, there's two different methods that you can use to solve for the number of solutions. It doesn't want to know what the solutions are, just how many does it have. So one option you have is using the graphing calculator. And you're looking to see how many times does it cross the x-axis. Notice on this one it does not cross the x-axis, so you're just going to put no real solution. Since it doesn't want to know what the solutions are, just how many, then you are done with that. You don't have to then go and use the quadratic formula and find the imaginary solutions. Now for number 12, the other option that you have, you can use this quadratic formula that we used on number 8, and you just have to use that determinant. Okay, so that b squared minus 4ac. So label our a, our b, and our c. We're going to plug that in. We're going to simplify this down. Alrighty, and notice how we get a positive number. If you get a positive number, it's going to have two solutions. If you end up with a negative number here, then you're going to have no real solutions. And if you end up with 0, then that just means there's going to be one solution. Alrighty, for number 13, they would have two parts for number 13 and 14. The first part is they want us to graph it. So thinking about our complex numbers, we need to change the axes. That this is going to be our real number line. This is going to be our imaginary number line. And so then our real number is 7, so we're going to go over to the right to positive 7. And then on our imaginary number line, we're going to go down to negative 2. So then we just plot that point. Again, these graphs are just going to be points. And then it says find its absolute value. So that equation is the square root of a squared plus b squared. So our 7 is our a, and our negative 2 is our b. And it doesn't matter the order in which you label your a and your b. So then you have 7 squared plus negative 2 squared. So 49 plus 4, which is 53. Now, if you can simplify this doing your factor tree, you want to simplify it. Since 53 is a prime number, we're just going to leave it. There's no pairs that we can bring out. So again, this is our graph, just a point, and then this is our finding the absolute value of the complex number. Now our next one, we want to graph just 8. So again, this is our real, this is our imaginary number, so we're going to go to the right 8. And then our imaginary number is just plus 0i, so we're not going up or down at all. We just make our point. And then we're going to use our equation, a squared plus our b squared. Simplify that down. And then this one does reduce, so we're going to reduce it down to 8. Now on the back side, number 15, it says find all the solutions to each use the quadratic equation. My hint for these, most likely if it says use the quadratic equation, that they're hinting at that you might have imaginary solutions. So we're going to take a look at this. We have our A, our B, and our C. Our quadratic formula I'll write up above, so if you don't have it down. So we have negative B, so negative 2, negative 2 squared minus 4 times our A times our C, all over our 2 times our A. So then we're going to simplify that down. So the two negatives cancel out to be positive. We have negative 2 squared, which is 4. And then here we have 4 times 2 is 8, times 5 is 40. So minus 40 divided by 4. We keep simplifying this down, so 2 plus or minus the square root of negative 36 divided by 4. Now notice how it is negative, so that means we're automatically going to bring out our I. That will change that to a positive 36. Square root of a positive 36 is just 6. So then our final answer is going to be 2 plus or minus 6i divided by 4. And you can leave that as your final answer, or another answer that I would accept. Notice each of these we can divide by 2, so we can divide each of them by 2 and reduce it further. Again, I'll accept either of those answers though. This next one, We're going to label our A, our B, and our C again. And we're going to start simplifying it down. And so we end up with -2 plus or minus the square root of -44 divided by 6. Again, we have a negative underneath our square root. So to make that positive, we're going to bring out an I. That'll change that to a positive 44. And then the square root of 44, we're going to try to do our factor trees, see if there's any pairs, see if we can reduce it further. So we have 2 and 22. 2 and 11. So notice we have a pair of 2's, so we can simplify this further, that we can put -2 plus or minus 2i square root of 11 divided by 6. I will accept this as an answer, or notice again each of these we can divide by 2, so -1 plus or minus 1i square root of 11 divided by our 3. The next one, it says solve each system by graphing. So for this one, notice they give us a system now. So instead of looking to see, when it says solve for the solutions, and it just gives us one equation, we're looking to see where does it cross the x-axis. Now it says solve this system, so they're giving us 2 or more equations. That means that we want to see where they cross one another. So we can do this either by substitution or elimination. So if we're using our, substitution or graphing. So if we do our graphing method, we have x squared and then -x squared plus 4. Okay, we can see this one crosses at 2 places, so it's going to have 2 solutions. So second trace, and then we're going to go down to 5. And then I'm going to find the one furthest to the left. So I'm going to move it over to the left so I can find that intersection of where they cross. Click enter. And then again, have it close to this intersection. Click enter, enter. And then it gives us -1.4. We can round that. Comma, and then 2. And then we want to go find the one on the right. So second trace, and then down to intersect again. But now we want to curve it over to the right side so it knows we are finding this coordinate over here. And then it is +1.4 and then 2. The other method that you could do for this, you could use substitution. So you could substitute this in for our y and then start solving for your x. Once you get your 2 x values, you're going to get -1.4 and +1.4. You would have to plug that into either of the equations and then solve for your y value. Alrighty, number 18 is inequalities instead. So we need to be thinking for inequalities, dotted or solid lines, and then shading. The shading where they overlap is the solution. So we're not writing coordinates like number 17. So we're going to go to the y equals. We have x squared plus 3x, and then x squared minus 2. Alrighty. The first graph that showed up was our first equation. So notice our first graph was the parabola on the left. So it kind of looked like this. And then our next one was the parabola on the right. So it looks like this, kind of. Okay. Both of these should be dotted lines. I didn't take a look at that. So I'm just going to make an arrow to them and put dotted line. If it was greater than or equal to or less than or equal to, that means that we need a solid line. And then from here, it's greater than this one and it's greater than this one. So if we shade greater than this one, and then greater than this one, it's above them. Notice the middle part is where they overlap, so that is your solutions. Again, you're not writing any coordinates. I just want to know where's the overlap. Number 19 and 21, you can cross those out. We're not going to have ones like that on the test. And then number 20, we want to know, explain the relationship between the x-intercepts of the quadratic function and the zeros of a quadratic function. So notice when it says solve for the solutions, we've been going on our graphing calculator, so it was second trace and then 0. So something that we need to make sure that we have down when it says solve for the solutions, or what are the zeros, or what are our x-intercepts where it crosses the x-axis, or if it uses the word roots, that those are all the exact same thing. So I don't want us to get confused with the terminology. Make sure that we know that each of those terms mean the exact same thing. Alrighty, last two problems that we're going to take a look at is 22 and 23. We're using our imaginary numbers. So for number 22, if we look in between the parentheses, notice there's no sign, so that means this is a multiplication problem, so we're going to have to FOIL. So we're going to distribute this 5. 5 times 5 is 25. 5 times 3i is 15i. Now distribute the negative 3i. Negative 3i times 5 is negative 15i. Negative 3i times 3i is negative 9i squared. Notice the middle terms are opposite, so they're just going to cancel out. And then our I squared equals negative 1. So anytime that you have an I squared in your answer that's not reduced, we want to reduce it further. So we have 25 plus our 9, which ends up giving us 34. Alrighty, last problem. Now notice number 23, even though they have the parentheses, we might be tempted to want to multiply it and FOIL again. However, this one has a minus sign in between, so they're wanting us to subtract. So we can do this two ways. We can either remember that that's a subtraction problem, so do 4 minus negative 1. The two negatives cancel out, so that would be 4 plus 1, which is 5. And then negative 2 minus negative 3. So negative 2 minus negative 3 would be negative 5i. Now if you think you're going to forget about that negative, I would maybe distribute a negative 1. So have 4 minus 2i, negative 1 times negative 1 is plus 1, negative 1 times 3i is negative 3i. And then just go ahead and combine your like terms. So 4 plus 1 is 5, negative 2i minus 3i is negative 5i. Those are not like terms, so we cannot combine them, and then we don't have an I squared, so we don't need to substitute in negative 1. Hopefully this helped. Please do let me know if you have further questions.